What we're going to do now is move it to a different data store. Select Migrate, Change Data Store, select Next. Now we're going to select this other data store. Select Next, select the thin format, select Next, and select Finish. So here it goes. It's copying the virtual machine files and moving the VM while it's still running over to the other data store. Depending on how big your VM is and how much disk space is in use, this can take anywhere from a few minutes up to even an hour or two if it's a really big VM. Since it's making it a thin disk, it's not copying that whole disk space over from one data store to another. It's basically creating a new disk on that other data store that's the size of only the data that's in use on that virtual disk file. So we're going to let this complete. Okay, that completed. The storage vMotion completed, and it moved it kept the VM on the same host, but just moved it to a different data store. And in the process, it actually converted the thick disk to the thin disk. So now if we edit the settings of the VM, select the hard disk, you'll see it's a thin disk. Now if you want to move that back to the original data store that it was on, you can do that. And you simply do a storage vMotion again and select the original data store, and just select the same disk format. Since it's already in thin disk format, we'll leave it there. Now if you don't have another data store and you only have one data store, you can't use storage vMotion to do this, but there is another way to do it, and that involves using the vmk-fs-tools command line utility, and we'll be showing you that later on. So to move this VM back, we simply select it, do Migrate, Change Data Store, select our original data store. We can select same format as source because it's already in the thin format, so we'll just leave it there in the thin format. Next, and then once you click Finish, it's done. That VM will be in the thin format and back in its original data store, and from that point on will be a thin disk. You can also inflate thin disks so they become thick disks by using the data store browser and selecting a virtual disk, and then selecting the inflate option. The VM must be powered off first though, or you'll get an error message saying that it cannot lock the file. Optionally, you can also use storage vMotion to convert a thin disk to a thick disk while VM is running by moving it to another data store, selecting the thick format, and moving it back again. Let's look at a demonstration of inflating a thin disk so it becomes a thick disk. Okay, here we're going to look at inflating a thin disk so it becomes a thick disk. Now the VM must be powered off to be able to do this. If you try to do it on a VM that's powered on, it's going to give you an error message, and we can show you that. If we select this VM that's powered on here, go to its data store, and select Browse Data Store. Then we go to the VM's directory, select the disk file. It's currently 0 KBs because it's a new VM and no data has been written to it yet. Select Inflate, and we get an error right away saying a general system error occurred, failed to lock the file. That's because the inflate procedure needs an exclusive lock on that file. Since the VM is powered on, the VM also has a lock on that file right now, so it can't do that. So we just say OK, close this. Now we'll go to a VM that's powered off, browse its data store, select the VM's directory, select the VMDK file, select Inflate, and there it goes. Now this process can take a while based on the total size of that virtual disk file. If it's a pretty big file, it can take several hours to complete. This one's only about 10 gig, so it's only taking about 20 minutes to complete. But that'll vary based on the size of the virtual disk file. It's basically creating a new virtual disk file and deleting the old one when it's done. So once that completes, that VM will have a thick disk and no longer have a thin disk. You can reshrink thin disks that have grown in size and have later had large amounts of data deleted from them by first using the Windows sdelete utility and then using storage vmotion. This is covered in the lesson on storage vmotion. The vmk-fstools command line utility can also be used to perform any of the operations that storage vmotion can do. However, unlike storage vmotion that can do this while a VM is powered on, vmk-fstools requires that a VM be powered off. There are also a few more steps involved in using vmk-fstools compared to storage vmotion, as you must remove, not delete, just remove, the disk from a VM, use vmk-fstools to clone the disk, which creates either a new thick or thin disk. Once that completes, you can add the newly created disk back to the VM, and finally delete the original virtual disk. For more information on vmk-fstools, see the ESX configuration guide in the documentation section of VMware's website. Appendix C covers how to use vmk-fstools. Here are some tips and best practices for using thin disks. Make sure you are aware of any snapshots in your environment which can affect the amount of free disk space on your data stores. Having two types of disk files that can grow on your data stores is a double threat. You can also set alarms for snapshot size, so it's a good idea to set them so you know when any snapshots grow too large so you can delete them. Avoid using thin disks with servers that will have disks that will not grow that much and will be near their capacity right away. There's not much benefit to using thin disks if a VM is going to be using most of its disk space right away. It's better to size your VM's virtual disks to what they will need and not give them space that they will never use. The greatest benefit of thin disks comes from servers whose disk space usage will start small and grow over time, such as file and database servers. If you have mostly static servers like application and web servers, just give them the disk that they need and don't go overboard. You can always grow the disk later on if you find you're running out of space. Make sure you monitor your data store free space carefully. There is a new alarm in vSphere to monitor data store free space called Data Store Usage on Disk that will alert you when your data store disk space usage grows to a defined percentage. Additionally, there is another alarm that you can set called Data Store Disk Overallocation %, which will trigger when your disk space overallocation reaches a defined limit. Let's look at a demonstration on configuring an alarm to help you manage thin disks. We're now going to look at setting alarms to help us monitor our data stores used with thin disks. Select your top level object, and that's where you want to set most alarms, because alarms set there will trickle down to everything else below that, like the cluster, the hosts, and the VMs. Next, select the Alarms tab. Here you can see a whole bunch of alarms already configured. We're going to configure a new one, so we select New Alarm. You give your alarm a name. Next, select an alarm type. And for data stores, we want to select data stores. Once you're done here, you want to go to Triggers. And this is going to set a trigger for a condition where we'll actually send an alert for if that trigger is true. So we go here to add a trigger. And there's a couple valuable ones for data stores. First is disk overallocation %. Now this is basically telling you when your data store is overallocated. It doesn't mean it's out of space, it just means that the allocation percentage is above a certain %. So let's say if we had a data store that was 100 gigabytes in size and we had thin disk VMs on there that were allocated up to maybe 300 gigabytes, this would alert us to that overallocation % condition, so we can be aware of how overallocated our data store is. You don't want to find out all of a sudden that your data store is now like 500% overallocated, which means it can quickly run out of disk space. So you can set the warning level, maybe at 150%. You can set the alert level, where it sends out an alert. Now the other valuable alarm is for the data store disk usage %. Now this is actually going to tell you when your data stores are filling up. So you can set a warning. Let's say maybe 80%. and an alert, let's say 90%. Now this is going to warn you when your disk space is close to being full, so you can take some actions like maybe deleting some files, moving VMs around, or increasing the size of your data store to prevent that data store from running out of disk space. Because if that data store ran out of disk space with thin disk on there, it would crash the VMs, or actually the VMs would suspend. So setting this alarm would help you be aware of those conditions where your data store is running close to being out of disk space. Now once you set these triggers, you go over to actions and you can configure an action for what happens when that trigger is activated. And you can send a notification email. You can direct that to a cell phone or a pager or to an email box. Or there's also another action here where you can send a notification trap. And with that you can send it to, if you have an existing monitoring system that has a SNMP, you can send the alert to that so you can be aware of it at that location. So that's how to set up alarms to help you monitor your data stores. Really important because you don't want to over allocate too much. You definitely don't want to run out of disk space on your data stores. The new storage view that we showed you earlier is very helpful. It shows detailed VM file information all in one view, including snapshot sizes, actual thin disk sizes, vswap, and other file sizes. Make sure you use this view so you can see all your VM file sizes at once. You can also click on the column headings to sort on them. Avoid doing operating system disk defragmentation on VMs with thin disks. This will cause the VM disk to grow very quickly, which may fill up your data store before you can react to any alarms that may trigger. One common question about thin disks is whether you should use thin disk inside VMware if your storage array supports it. This is referred to as thin on thin. Use both if you can. Just make sure you carefully monitor your overallocation on both the array and the VMware sides to ensure that you have adequate space available. In VI3, if a data store ran out of space, it could crash and corrupt your virtual machines. In vSphere, a new safety mechanism was added that will suspend VMs if a data store becomes critically low on free space. This will give you some time to free up some space before you resume the VMs. Oftentimes you can delete snapshots or move VMs to other data stores to free up space. You can also grow the VMFS volume by increasing the one size or by adding an extent to it. Here is a link to the performance study that VMware did on thin disks. It shows their testing methodology and results that confirm that the performance impact on thin disk is negligible. Thin disks are a great way to conserve wasted disk space, as most VMs are allocated more storage than they will ever use. In this lesson, we have learned how thin disks work and the differences compared to thick disks. We also learned how to effectively utilize thin disks, as well as tips for changing disk formats. That concludes this lesson on thin disks. Thanks for watching, and I'll see you in the next one.